Very good morning student. This is the lecture of object oriented programming using C++. We have already started our fourth unit, that is the pointers and polymorphism in C++. We will see the COs which is related to this unit, that is after completion of this unit you will be able to use polymorphism in C++ program, and these are the unit outcome related to this unit. In the previous session we have started our second subpoint, that is pointer to object. So in that we have seen how to create pointer of an object and also this pointer. Now in this today's session we will start this 4.2.2, that is a pointer to derived classes. So the concept of derived class in C++ specifies hierarchical relationship between various objects and express the commonality between them. The properties common to different classes are placed at the top of hierarchy, which becomes the base class, and all other classes are derived from this base class. So in this pointer to derived classes concept, we are going to see how to create pointer of a derived class and base class, or how pointer works in a inheritance. So pointers in C++ can be used with the objects of base classes or derived classes. Pointer to objects of a base class are type compatible with pointers to object of a derived class, thus allowing a single pointer variable to be used as a pointer to object of a base class and its derived classes. Means what? In this concept we can use same pointer for base class also and derived class also. Okay, there is no need to declare two different pointers for base class and derived class. Only one pointer is sufficient to assign the address of a base class also and derived class also. Okay, for example, if B is a base class and D is a derived class from B. Okay, so B is a base class, D is derived class which is derived from the class B. Then the pointer declared as a pointer to be B can also be pointed to D. Means a single pointer can point the object of a B class also, that is a base class also, and derived class also. So see here, B star CPTR. Here C pointer is the pointer of base class. Now B, small letter b is the object of class B, D is the object of class D. Now CPTR is equal to address of B. Here we are assigning the address of base class object to the C pointer. Now we can make CPTR to point to the object D as follows, like CPTR equal to address of D. Means here in the first sentence we are assigning the address of object who is the object of class B, that is a base class, and here in this sentence we are assigning the address of object D, which is a derived class object. So this is perfectly valid with the C++ because D is an object derived from the class B. However, there is a problem in using CPTR to access the public members of the derived class D. So here is a very important sentence. Remember, we can use same pointer for the base class and also derived class. There is no any issue regarding this, because the derived class is derived from the base class, so all the members of the base class is derived in the derived class. But problem is where when we write extra member functions or members in the derived class, so this type of members cannot access by using this pointer, because this pointer is same for the class base class and derived class. Okay, using CPTR we can access only those members inherited from B and not the members that originally belongs to D. Means all the inherited members from the base class we can access by using the pointer, but which are the members who are declared in the derived class only, we cannot access this type of members using this CPTR. In case a member of D and the has the same name as one of the member of B, any reference to that member by CPTR will always access the base class members. Means what? Uh, Suppose there is a one case like derived class and base class has the member which has the same name. In that case, the CPTR always access the base class member, not the derived class member. Although C++ permits a base pointer to point to any object derived from that base, the pointer cannot be directly used to access all the members of the derived class. We can access all the members of the base class only, not for the derived class. We may have to use another pointer declared as a pointer to derived type. Okay, C++ makes polymorphism possible through a rule. Base class pointer may address an object of its class or an object of any class derived from the base class. Means this pointer is used to access the members of the base class and all the other classes which is derived from the base class. So here the diagram, a base class pointer may address a derived class object. In short, base class pointer can point to derived class. So using base class pointer, we can access derived class member. So here object of a base class, object of a derived class, and again object of the another derived class. So in a derived class pointer, a derived class pointer may address objects of the derived class but not objects of the base class. And base class pointer, a base class pointer may address object of the base class or object of any derived class. Means suppose if we if we define pointer in the base class, then that pointer can access the object of base class also and derived class also. But if we declare pointer in the derived class, then it can only access or it can contain only address of the derived class object, not for the base class object. Now we will see one program for pointer to derived class. So see here, class base class is a base class having the private data member as an integer x, and in the public section there is two member function, that is setX and getX. In the setX we are assigning the value I to the x, and in the getX we are returning the value x. Now see, here is a derived class, derived class which is derived from the base class, and the visibility mode is a public, means all members of the base class is inherited into the derived class. And here integer y is a data member of the derived class. And public in the public section there are again two member function, that is set y and get y, which is used to assign the value to the y and return the value of y. Now see here in the main class, here we are creating base class pointer for the base class, that is a star p. Now object of a base class is a base object. Now derived class, and derived object is the object of the derived class. Now p equal to address of base class, means what? Here in the p pointer we are assigning the address of this base class. So p arrow set x 10. Now here we are accessing the public member function of the base class by using the pointer, and here we are assigning 10 value to the x. Now see out base class object s equal to get x. Here it will print the value of the x, that is a 10. Now see here p equal to address of derived object. Here we are assigning the address of the derived object to the p. Here again p set x 99, derived object, that is a set y. So see here, by using this base class pointer we are accessing the derived class object. But we can't use P to set Y, so do it directly. Means what? By using the P dot set Y, we cannot use this sentence. Why? Because P is the pointer of the base class and set Y is the function of, here you can see, set Y is a function of derived class. It is not inherited from the base class, so we cannot access the set Y function by using the pointer. Now derived object P arrow get X, and here derived object dot get Y. Here 10 is the value of X, 99 is value of object X by using the derived class, and 88 is value of the Y. So this is the program which shows how pointer works in the base class and derived class. Okay, in the next section, this is the next point, that is a third sub point, that is the introduction to polymorphism. Now polymorphism is a Greek term that consists of two words, poly and morph. So poly means many and morph means form. So same name and different form is known as a polymorphism. So polymorphism means one name, many forms. Polymorphism is the process of defining a number of objects at different classes into group and call the method to carry out the operation of the object using different function call. Now see here, types of polymorphism. There are two types of polymorphism, that is a compile time polymorphism and runtime polymorphism. First we will see the compile time polymorphism. When the required information to call a function is known to the compiler at the compile time, it is known as compile time polymorphism, also called as the early binding or static binding. When the required information to call a function is known to the compiler, means before going to compile the program, before going to execute the program, if we provide the information to the compiler to function call, then it is known as the compile time polymorphism or early binding. The process of linking a particular call statement with a particular definition is called as binding. Means what? Passing the parameters to the function call is known as the binding. Early binding is the binding that an object is bound to its functional call at the compile time. Early binding is implemented using operator overloading and function overloading. The main advantage of early binding is efficiency and disadvantage is the lack of flexibility. So efficiency, what? If at the time of compilation, if we provide the information to the function call, then it is easy to execute. Okay, but what is the disadvantage is that we cannot give value at the runtime. So it is a static, we cannot change this value. If we want to change the value, then we have to change into the program. Next is a runtime polymorphism. When the required information to call a function is known to the compiler at the execution time or runtime, it is known as a runtime polymorphism, late binding or dynamic binding. So dynamic binding is a binding that appropriate function is done at the runtime. Dynamic binding that requires the use of pointer to objects. The main advantage of dynamic binding has better flexibility than static binding. The dynamic binding is implemented using virtual function. The word virtual means existing in effect but not in reality. So a virtual function is the one that does not really exist but appears real to some parts of the C++ program. This see this diagram: polymorphism, compile time polymorphism and runtime polymorphism. So it has the again two points, that is a function overloading and operator overloading. These are the compile time polymorphism, and virtual function is the runtime polymorphism. So now we will see the difference between runtime polymorphism and compile time polymorphism. So compile time polymorphism: when a compiler acknowledges all the information required to call a function or all the value of the variable during the compile time, it is called as a compile time polymorphism. means before the program execution, if we give all the values for the variable, then it is known as a compile time polymorphism. Calling a function or assigning a value to a variable at the runtime is called a runtime polymorphism. Means what? After execution of program, if we providing the value to the variable, then it is known as a runtime polymorphism. In compile time polymorphism, call is resolved by the compiler, and in runtime polymorphism, call is not resolved by the compiler. Why? Here in the compile time, already values are given before the function calling, and here in the runtime, after execution of the program, we are passing the value for the call the function. It is also known as the static binding or early binding, compile time binding. It is known as the dynamic binding, late binding, or runtime binding. Compile time polymorphism achieved by function overloading and operator overloading, and runtime polymorphism is achieved by using the virtual function. Now, compile time polymorphism provide fast execution because known early at the compile time, because we are providing information before the execution. So it provides the fast execution, and it provides slow execution as compared to the early binding. Why? Because it is known as a runtime. We are providing value after the execution. So compile time polymorphism is less flexible as all things execute at the compile time. As I tell earlier, that is we can pass the value during the program before the execution. So what if we want to change the value of the variable, we have to change into the program. In the runtime polymorphism is more flexible as all things execute at the runtime. Now example of the compile time polymorphism is a overloaded function call and overloaded operators. An example of the runtime polymorphism is a virtual function. This is about the polymorphism.